Good morning, students. Today we are going to discuss a very important topic, mechanism of concentration of urine. So how urine is going to be concentrated or dilute. So for that, before going into the mechanism, just listen. For example, if this is the concentrated urine, so for the urine to be concentrated, the water has to be reabsorbed, and the hormone which is responsible for reabsorption of water is ADH, which will be present in collecting duct. So what this ADH does, it absorbs the water, so which causes the urine to be concentrated. But that's not as simple, because this water to be reabsorbed, I require a gradient, osmotic gradient. So only if there is osmotic gradient, the water can be reabsorbed by the process of osmosis. ADH is needed, accepted, anti-diuretic hormone. As the name suggests, ADH will help in reabsorption of water. As the water is reabsorbed, I get a concentrated urine. So wherever I need a concentrated urine, that is done. But I require a gradient, osmotic gradient. So for example, if you are, imagine 1200. So this is interstitium. This is medullary interstitium. So if there is hyperosmolarity, we call that as hyperosmolar medullary interstitium. So if there is hyperosmolar, that is 1200 milliosmoles. Here also, this is also interstitium, medullary interstitium. So now imagine, if there is 1200 milliosmoles or hyperosmolar, so this area, this interstitium, medulla, this is in the medulla. So this part is cortex, this part is medulla. So if the medullary interstitium is 1200, here the concentration is more. So what will happen? That will absorb the water. So now this attracts the water. So the 1200 milliosmoles is driving the water, the gradient osmosis process, and ADH is helping in that. So I require ADH as well as this hyperosmolar medullary interstitium, hyperosmolar medullary interstitium. So now I understood how the water is absorbed and how I get a concentrated urine. Okay, understood. Now the next question, how to get this 1200? This is medullary hyperosmolar interstitium. How to get? Question. So how? We call that as CCM, countercurrent multiplier. Countercurrent multiplier is one mechanism by which the medullary interstitium is becoming hyperosmolar, and another one is urea recycling. So this 1200, how I get this 1200 medullary interstitial hyperosmolarity? One is countercurrent multiplier, which I am going to explain now. Another is urea recycling. So only if this both is taking place, I will be able to get the 1200 medullary interstitium. This countercurrent multiplier is well developed in cortical nephron or juxtamedullary nephron. You can pause the video and try to answer. Obviously, you will know the answer because medullary interstitium 1200. So this countercurrent multiplier is the one which is responsible for medullary. See the name medullary. So obviously, juxtamedullary nephrons are the one which is going to make the countercurrent multiplier mechanism, not the cortical nephrons. So cortical nephrons will have a small loop of only. The cortical nephrons will not come up to the medulla. I have written here. This is medulla. This is cortex. So again, if I ask, short nephrons will be making high hyperosmolarity medullary interstitium or long nephrons. Obviously, the answer is long nephrons. Note it down. As long as the nephron is long, the 1200 will be achievable easily. We are ready to go into the mechanism. Now, let me go to countercurrent multiplier. Countercurrent multiplier, CCM. So, first question, which acts as countercurrent multiplier? The answer is loop of Henle, which are drawn descending limb, ascending limb. So, loop of Henle. Now, just imagine, we all know plasma osmolarity is 300 milliosmoles. So, whatever is going to enter into proximal convoluted tubule is 300 milliosmoles. So, we will start with hypothetical imagination. So, just imagine the counter mechanism is not going to happen. So, what will happen? It will be 300. Just you can see the osmolarity is everywhere 300 because we have not started. The countercurrent multiplier has not yet started. Loop of Henle has not yet started to work. So it is everywhere 300. Imagine if this is the scenario, I will ask you everywhere. So this is interstitium, very very important. Medullary. So according to this diagram now, the medullary interstitium is 300. So here also it will be 300. Now imagine if I want the concentrated urine, which I was telling in the starting of the lecture. So will I be able to observe as much as water possible? No, because osmotic gradient, the process of osmosis is getting affected. So I want this 300 to be converted to 1200. That's what we are going to discuss. So now the first step, I am starting with everything is 300. So this is the first step. Now what happens, imagine in the ascending loop of Henle, we start the diagram. So there is sodium, potassium, 2-chloride transporter. So next step. So just imagine in ascending limb of loop of Henle, there is a transporter, sodium, potassium, 2-chloride is an active transport. So what it does is sodium chloride. So because of the sodium potassium 2-chloride transporter which is present in ascending limb of loop of Henle, sodium solute, sodium and chloride is coming in. Now, so now every step is very important. It might mean look difficult on your written book, but after seeing this video, I will make it as simple as possible. Now tell me what will happen to this 300. See, sodium is coming, chloride is coming. So this 3 will now become 400. So what will happen to this 300? Since sodium and chloride is coming inside, this is 200. So this is 200. This is 400. So first step. Now, why from 300 has changed to 400? Yeah, sodium which is a solute, chloride which is a solute. So concentration is increasing here. Why here it is decreased? Sodium has gone, chloride has gone. So here this is 300 is coming from the glomerulus. Now next step. Second step. And always remember, descending limb of loop of Henle is permeable only to water. It is impermeable to solutes. Very very important. Same ascending limb of loop of Henle is permeable to solutes, impermeable to water. So this is not permeable to water, and this is not permeable to solute. Yeah, that is very important point which you have to remember. So first step is over. Now second step. Now you can see here. So now what descending limb of loop of Henle will think is, there it is 400, here it is 300. So 300. So 300, 400. So there is a mismatch. So now what it will do? Now this will start sending water. See here, see how interesting it is. This will send water. Second step is descending limb sends water to interstitium. Now imagine what will happen to this 300. Yeah, this again may become 400. This also will become 400. Now see here 400, 400, 400, 400. Yeah, same here also you can convert 400, 400. So why this 300 has converted to 400? Because solvent is lost. Water is going inside, so the concentration is increasing. So this is second step. Now it is balanced. Now some students, they will ask, sir, here water has come. So this water will dilute this 400. No, sir, how this will be 400? It has to again reduce to 300. So you people will have doubt. The water which is entering into the interstitium will dilute this osmolarity, this medullary interstitial osmolarity. So every time water comes, it has to dilute. So keep that question. You try to answer in the comment box. If you know the answer, I will tell the answer a little bit later. What happens to the fate of this water which is entering into the interstitium? Why this water is not diluting the interstitium? That I will tell later. Okay, now this is the second step. Yeah, now this is 200 only. See here, just listen. Here it is 200. The osmotic is very less here. So how to take the sodium and chloride? Because I want 1200 is the maximum. Note it down. I want medullary interstitial osmolarity to be 1200. But here now listen here, 200, 200. So here and here also it will continue, 200, 200. Then here also some sodium will be lost, 100. That's why this is called diluting segment. Usually distal convoluted tubule, we also call it as diluting segment. 200 is gradient is, the osmolality is very less. So this process where a first step, sodium and chloride getting absorbed, becomes difficult. Now what happens, note it down. Now coming to third point. So first point is this, second point is this, now third point is this. See here, this 400 will come here. Or otherwise, note it down, I will write it here. Descending limb provides osmolarity to ascending limb. Very, very important point. So note that I have put in a box. Descending limb provides osmolarity to ascending limb. See, descending limb, this 300 has become 400. What happens to the fluid, the glomerular filtrate in the descending limb? Yeah, it has to come through the loop of Henle, that is descending limb, then thin ascending limb, then thick ascending limb. So this 200 has now become 400. Now listen, what will be the next step? This 400. So from here what will happen? Sodium chloride through this. So sodium chloride is coming. So what will happen? So this 4 will become 500, 500, 600. So now just listen. Why this 400 now has become 500? Yeah, because sodium is coming, chloride is coming. Why sodium and chloride is coming from ascending limb? Because the descending limb, as I written, the descending limb provides the osmolarity to the ascending limb. Now next, you should be knowing the answer. So here it is 400, here it is 500. Again there is a mismatch. So now what we'll do? Yeah, this again repeats. Already it is there. So now again the water goes. So this may become 500, 500, 500. Again this 500. So now the 500 is high osmolarity. So what happens? Again this process. The sodium and chloride will be coming through the sodium, potassium, 2 chloride. So this 1, 2, 2, 3. 1, 2, 3 steps. So I again repeat, first step is sodium, potassium, 2 chloride transporter, which is giving hyperosmolarity to the interstitium. Second step is the descending limb is getting hyperosmolar to maintain the osmolarity with the interstitium. Third step is, so I will write it, third step, first step, second step I have written. So first step, second step, third step, third step. So now this process keeps on going. So descending limb function, it gives water to the interstitium so that the descending limb is hyperosmolar. Ascending limb, it gives the solids to the interstitium so that interstitium becomes hyper. That's what I want. I want modular interstitium to be hyperosmolar so that water can be reabsorbed whenever it is needed with the help of ADH. So this process keeps on going until I get 1200. Here it may be 1800, 500. So you can see that the osmolarity gradually increases up to the tip of the medulla. Usually tip of the medulla, the osmolarity will be more because it is more close to the medulla. And here and all the osmolarity will be less because this has crossed the loop of Henle. And here even it can even come to 60. That's why distal convoluted tubule is called as dilating segment of the nephron. Now next question, why this is called as countercurrent multiplier? Yeah, it is like max, you can see here. We started with all is 300, then here it became 400, 500, 600, 800, finally 1200. So it is multiplying. From 300 it has 500, 600, 800, 1000. It has came to 1200. That's why this is called as countercurrent multiplier. Why countercurrent? Counter means opposite. Current. So one is flowing in downward direction, descending limb of loop of Henle. Another is flowing in upward direction, ascending limb. So they both are going in opposite directions. So counter current. Multiplier is From 300 it has reached to 1200. So here also now no 300, it will be 1200. This is cortical collecting duct. This is medullary collecting duct. So I have here shown in a single diagram, but when you are going to write in the exam, you can first draw a diagram of 300, 300, 300. Next step, draw the first step. That is 300 becoming 400 in the interstitium, or 500 in the interstitium. Then next step, you draw descending limb, which is 300 becoming 400. So that 400, 400 or 500, 500. It is like same. So whatever I rubbed, you draw it in a separate diagram, because in exam you can't rub and redraw. Are you able to understand? So since due to lack of space, I was explaining in a single diagram, but in exam you have to draw it separately. So the first diagram will be all is 300. The second diagram will be the first step. The third diagram will be the second step, this blue color arrow. The fourth diagram will be the osmolarity. Fifth diagram, change this concentration. The concentration keeps on increasing, 500 items. So until 1200. Now next interesting question. Why there should be U shape? Why there should be a counter current? What if the nephron is like this? So instead of this, if it is like this, what is the problem? Or otherwise, if the nephron is straight, why the 1200 may not come? First I will ask, you pause the video and try to answer. If the nephron is straight, whether you will be able to get this 1200 milliosmoles osmolarity? The answer is no. Maximum it can increase only up to 200. The reason is obvious, just now I explained. Only if it is descending and ascending, one will be sending water, one will be sending solute. Only if it sends the solutes, the concentration increases. For it to send the solute, I need here the concentration to increase. So initially it was 300, now it become 500, because the descending limb is providing the osmolarity. So listen here, if it is straight, the third step will not occur. No third step. Third step is the descending limb providing the osmolarity to the ascending limb. If it is straight, there is no descending limb, no ascending limb. So the hyperosmolarity can never go up to 1200. Note it down. So for the countercurrent multiplier to perform properly, if you want to get the medullary osmolarity to be 1200 or medullary hyperosmolarity, we call that as medullary hyperosmolarity. If you want that, you should have a descending limb, ascending limb. It should be just a medullary nephron. Yeah, one question I asked. This water should dilute now. This is 1000. When water keeps on coming from the descending limb, here it is increasing accepted. 500 will become 600, all those things. But this 1000 should decrease now. 600 should come 400, 400 should come 200. So what is the fate of this water, I asked. So now we understood. Countercurrent multiplier is responsible for production of this 1200. Okay, let us stop that. Again, if you have found out the answer, you try to answer. What is the fate of this water? Before that, one more thing is there. Note it down. Urea. So this is urea. So urea recycling. Note it down. Urea recycling is second step. Countercurrent mechanism is first step. For 1200, 1 and 2. So note it down. Urea is a solute. So urea is also a solute which is going to give some concentration. What happens? Urea recycling occurs in medullary collecting duct. Urea recycling occurs in medullary collecting duct, not in cortical collecting duct. Note it down. Definitely not in DCT, not in loop of Henle. Urea recycling starts only in the medullary collecting duct. Now I will tell the importance of urea recycling. Imagine if urea recycling does not happen, only countercurrent multiplier. So far I have explained countercurrent multiplier, CCM. If only countercurrent multiplier happens, this 1200 will be only 600. Now you can ask me, sir, so far you are telling how this 1200 came, how can it be 600 only? Means so far I was telling this concentration solute, the descending limb is giving, the sodium and chloride is coming, but this urea will come from here into the interstitium, urea, and this urea is entering here. and the urea is here. And remember, urea is not reabsorbed in ascending limb of loop of Henle. This urea keeps on going. This is called urea recycling. So if this urea is not entered here, the solute concentration may be little bit less. Even though the descending limb is providing, this urea is also providing the solute concentration. And that including that urea concentration only we are so far mentioning that 300, 500, 800, 1000, 1200. So urea recycling is also an important step in bringing the interstitium, and the urea is not coming here because urea, the ascending limb of loop of Henle is not permeable to urea. It is permeable to sodium chloride but not to urea. But the importance of urea is because of this urea recycling, the urea is also added to the concentration of solute, and only if the concentration of solute is more, the sodium and chloride, for listen here, for this concentration is needed here. So only if it is 600, more sodium and chloride is going to be reabsorbed. Only if it is 700, more sodium and chloride is to be reabsorbed. For this to become 600, 700, 800, I require urea recycling. See here, the urea from the medullary collecting duct is reabsorbed through urea transporter. It is entering into the loop of Henle, ascending limb of loop of Henle, and goes to distal convoluted tubule, cortical collecting duct, medullary collecting duct, again reabsorbed. So this is a cycle, you can see here. Yeah, this is urea recycling, very important. Urea recycling also plays a very important role in creating this 1200. So far we have discussed how the medullary hyperosmolality of 1200 we obtained, which is called a countercurrent multiplier, as well as urea recycling. Yeah, now coming to the question. Third time I am asking this question. This water should dilute the interstitium and our entire thing is collapsed. The 1200 we want to maintain, but what happens to the fate of this water coming from the descending limb? If it is going to be in the interstitium, it is coming to the interstitium only. If it is going to be in the interstitium, won't it dilute? The answer is no. Fate of this water, so it is not going to dilute the interstitium. So where it is going to go? So this is efferent arteriole. So what happens? Yeah, this is the efferent arteriole. It is also making a U shape. So this is descending limb of vasa recta. Note it down. This is vasa recta. So note it down. Vasa recta are peritubular capillaries, which are nothing but continuation of capillary network of efferent arteriole from the glomerulus. This is efferent arteriole. This is afferent arteriole. So efferent arteriole continues as peritubular capillaries, which is vasa recta, and vasa recta is also having descending limb, ascending limb, and this is loop of Henle. Here I have just compared. So this is loop of Henle. So in loop of Henle, this is descending limb. Yeah, this is ascending limb. So just here, the descending limb of vasa recta is parallel with ascending limb of loop of Henle. The ascending limb of vasa recta is parallel with descending limb of loop of Henle. So what happens? This water, as I already drawn, all this water enters into the vasa recta. This ascending limb. This is descending limb. So what descending limb does is, this is 1200 interstitium. So solutes, sodium chloride, sodium chloride, sodium chloride. So from 300. So remember, vasa recta is a capillary network. So plasma osmolality should be maintained 300, and as well as simple, the function of vasa recta, the plasma osmolality should be maintained 300, accepted 300. At the same time, as I was mentioning, imagine if this vasa recta is not there, this water, the blue color, this water would have diluted the interstitium. So what will happen? The 1200 I wouldn't have got. Only if I get this 1200, I will be able to absorb the water with the help of ADH. I require that osmotic gradient. So 1200 is needed. So that is how the vasa. So vasa recta is maintaining. Note it down. So loop of Henle is producing the medullary hyperosmolarity. Vasa recta is maintaining the medullary hyper. That is the difference. So if they specifically ask countercurrent multiplier, it is Looper friendly. If they are asking how the urine is concentrated, it is countercurrent multiplier, which is Looper friendly, as well as urea recycling, which is also helping. In fact, if urea recycling is not occurring, there will be only 600 milliosmoles. So another 600 milliosmoles is because of urea recycling. That also you should remember. Now vasa recta here. So now what happens when it is coming down? 300, 600, 800, 1000, 1200. Now same thing as I explained for loop of friendly. If this vasa recta is not U-shaped, listen, you can try to pass the video and answer. If the vasa recta is like this, so this is vasa recta, so 300, 600, 800, because sodium chloride is coming. So imagine if the vasa recta, that is the peritubular capillaries, is having 1200 milliosmoles, osmolarity, what will happen? Just imagine. We can't even think 1200 milliosmoles in a peritubular capillary. That is no way possible. That's why the nature has created the vasa recta to be U-shape. Yeah, you can see here the U-shape. So now what happens? Yeah, 1200. Since water is already, now what will happen? This 1200 again, 800, water, 600, 400, 300, 300. So just concentrate. We started the vasa recta osmolarity with 300, but as solutes are entering from the interstitium, the solutes are entering. It takes the solutes, what happens? 300, 600, 800, 1000, 1200. But in the ascending limb, what happens? It takes the water from the descending limb. So again, it comes to 300. So vasa recta osmolarity is maintained, but as it does, the exchange is occurring. It is taking the sodium from the ascending limb. It is taking the water from the descending. So note it out. Vasa recta is counter current exchanger, very important, exchanges, and it maintains. All these points are very important. Vasa recta is countercurrent exchanger. Why countercurrent? Again, you can see here descending limb, you can see here descending limb, ascending limb. Descending limb of vasa recta is parallel with ascending limb of loop of friendly. Ascending limb of vasa recta is parallel with descending limb of loop of friendly. So countercurrent. Why exchanger? It exchanges solutes and water with loop of friendly. Note it down. Vasa recta exchanges solutes and water with loop of friendly. Very important. So that's why water is not able to dilute the interstitium, because the vasa recta is maintaining that 1200. So 1200 is produced by loop of friendly as well as urea recycling. Loop of friendly, the mechanism we call as countercurrent multiplier. Why multiplier? We saw 300 becoming 600, 600 becoming 800, 800 becoming 1000, all those things. And how vasa recta is maintaining that we saw now. So very difficult topic. Even now, if people have not understood, just watch the video again, and you can even pause for every frame and think what has been explained, so that you will be able to understand it still easily. So the final summary is, remember the 3 steps, simple. Yeah, you try to answer yourself. First step is ascending limb of loop of friendly giving sodium and chloride. So ascending limb is giving the sodium and chloride to interstitium. Sodium and chloride to interstitium. Second step is, you answer yourself. Second step is, yeah, descending limb of loop of friendly giving water to interstitium. Don't worry, water will not dilute the interstitium. Just now we have explained that. This is descending limb, concentration will be increasing. Third step is, descending limb of loop of friendly provides osmolarity to ascending limb. And what ascending limb does? Ascending limb provides osmolarity to medulla. So it is a cycle. Descending limb is providing osmolarity to the ascending limb. Ascending limb is providing the osmolarity to the medulla. Medullary hyperosmolarity is maximum up to 1200, and 1200 is help to take the water with the help of ADH, and that's how you get a concentrated urine. Very simple. Now to get a dilute urine, ADH is not going to act. ADH property is anti-diuretic hormone. It has to absorb the water. But here what happens for the dilute urine? The urine as such goes. So it is not going to act. I don't require this 1200 for producing a dilute urine. So this 1200 is mainly required for producing concentrated urine. That's why mechanism of concentration of urine, very very important. And any drug which acts on the sodium potassium 2 chloride transporter, if I inhibit that, then what will happen? This process so far what I explained, the sodium absorption, chloride absorption, the first step, that will be affected. So what will happen? Whether I will get concentrated urine or dilute urine, I will get dilute urine. Dilute urine means more urine. That's why it is called as loop diuretic. So loop diuretics are a type of diuretic which inhibits this sodium potassium 2 chloride transport. The first step is affected, that is loop diuretic. So I don't want to go into detail. That today's video was mechanism of concentration of urine and how it is produced, how the medullary hyperosmolality is produced by loop of Findlay and urea recycling, and how it is maintained by vasa recta. So hope you understood this video. It is a very very important video, a difficult video, because we get confused why 300, 800, this side 400, that side 500, but I try to explain as much as possible. We'll meet in the next video. Thank you. So if you like this video, please subscribe, comment and share this video to your friend circle so that it will be useful to all of them. Thank you. We'll meet in the next video.